Okay, welcome back. This time we will solve this trigonometric integral of sine power of 8x over sine power of 8 plus cosine power of 8. But as you can see here, the Wolframalpha solve it for us, but you can see the solution here is very complicated. But as you will see later in this video, we can find a much more simpler solution. This is a challenging trigonometric integral because it is not easy to solve this one. So first I will let I as this integral, and then I can write this in another way. This is just plus 0, so I can change plus 0 by plus cosine power of 8 minus cosine power of 8. And then notice that here the numerator here, sine plus cos over sine plus cos, so I can break this, and this will be 1. So we have the integral of 1 is x, and then minus the integral of cosine power of 8 over sine power of 8 plus cosine power of 8. And so if I add both of these form right here, this one and the original one, we get here 2i is equal to x plus the integral of the difference over the addition. Okay, so this will be the integral we want to solve now, because if we solve this, then we just divide by 2. We simplify the numerator and denominator. Sine power of 8 minus cosine power of 8 is equal to this. Sine power of 4 minus cosine power of 4 times sine power of 4 plus cosine power of 4. And the first will be sine squared minus cosine squared times sine squared plus cosine squared. And the other one is sine squared plus cosine squared squared minus 2 sine squared cosine squared, because this will have 2 times sine squared cosine squared, so we have to cancel by this. And since we know that well known that is sine squared plus cosine squared is 1, so we have this. This is 1 and this is 1, so we have this. Now, so the integral, the numerator becomes this. Now let us simplify the denominator. Similarly as before, sine power of 4 plus cosine power of 4 squared will have sine power of 8 plus cosine power of 8, but it will also have 2 times sine power of 4 cosine power of 4, so we have to cancel by this. Okay, and then again using the same using a similar way, we write this sine power of 4 plus cosine power of 4 as sine squared plus cosine squared squared. And then don't forget to cancel by 2 sine squared cosine squared. So, and since this is 1, sine squared plus cosine squared is 1, so we have this. Notice that here we have in terms of sine times cosine. Here sine times cosine, and also in the numerator we have sine times cosine, except the sine squared minus cosine squared. Okay, so the integral is this now, and it looks like we may want to use the substitution u equals sine x cosine x. By using this, the derivative is the difference of cosine squared minus sine squared. And in the numerator we have here, this is actually the minus of the u prime. So by the substitution, we get that 2i is equal to x plus the integral of minus du over dx, because if we take the minus of this u prime, we get sine squared minus cosine squared, and then 1 minus 2u squared over 1 minus 2u squared power of 2 minus 2u power of 4. Okay, and then so we can cancel the dx, and we have this one right here. So let us compute this integral right here. Okay, so we want to compute this. First, notice that the denominator is the difference of 2 squares, because 2 times u power of 4 is square root of 2u squared, all being squared. So we can factor this difference of squares. 1 minus 2u squared, that is this one, minus square root of 2 times u squared. Right? This is the square root of, all of this is the square root of 2u power of 4. And then this one right here also, we have this, the second factor. Okay, so then we want to simplify this by combining the u squared. We get this, 2 plus square root of 2u squared and 2 minus square root of 2u squared. And then using partial fraction, it is very easy to check. You can check by yourself. By partial fraction, we get this. We break it up into these two terms. Each has coefficient minus half here. So this is the integral that we have to compute. And now let me use substitution now. This, let alpha be the square root of 2 plus square root of 2 times u here. So this will be that du equals to d alpha over square root of 2 plus square root of 2, because if I can let this as alpha squared, so we have 1 minus alpha squared, and we can factor out again. So we have here, and then also for the second integral, we also let beta be square root of 2 minus square root of 2 times u. And then, because all of this is the square root of 2 minus square root of 2 times u squared. The square root of this is this one, beta. So we have du equals d beta over square root of 2 minus square root of 2. So by that substitution, we get this one. The integral becomes this, because we just changed the du here. So we have d alpha and d beta now. Okay, so we have 1 over 1 minus alpha squared and 1 over 1 minus beta squared, and that makes it simpler because we can factor the difference of squares again. Okay, so we have here, and then notice that integral of 1 over 1 minus x squared dx, we can factor out the denominator and then using the partial fraction, and we get this one. You can easily check that. This is an easy partial fraction, and each of this is ln. For this first one is minus ln 1 minus x, and this one is ln 1 plus x, and then times half. So we get this ln of square root of 1 plus x over 1 minus x. So we get here all of this. All of this will be equal to this. We just change the integral by ln square root of 1 plus alpha over 1 minus alpha for the first one, and the second one is this. Ln of square root of 1 plus beta over 1 minus beta. And this is the result. And lastly is what we want to do is we just change the variables. Alpha is just square root of 2 plus square root of 2 times u, and then beta is square root of 2 minus square root of 2 times u. And then u is just sine x times cosine x. So this is the result. Okay, but this is not the original problem, because the original problem is this one, and it is equal to I equal to x over 2 plus the integral that we have just computed. So this is the indefinite integral, the result. So let us check whether this is really the integral of this function right here. In other words, if we take the derivative of the result right here, the answer on the right hand side right here, it must be sine power of 8x over sine power of 8x plus cosine power of 8x, right? Now this is the graph of the function sine power of 8 over sine power of 8 plus cosine power of 8. As you can see here, it is always positive, of course, because the powers is even. And notice here, if it is positive, it means that if you treat the the sine power of 8x over sine power of 8 plus cosine power of 8 as the first derivative of some function, then this means that that function must be increasing because the first derivative is always positive right here, positive or 0 right here. You can see here it is 0, always 0, and at other place it is always positive. And the plot of our answer is this. This is the result, the answer that we have computed, right? And as you can see, it is consistent with the function sine power of 8x over sine power of 8 plus cosine power of 8, because as you can see here, this is where the derivative is 0. You can see it is flat, so first derivative is 0. So this is the answer of the integral, the challenging trigonometric integral. Thanks for watching and see you on my next videos.